specialize in technical art, graphics programming, and consulting. Apart from that, we also publish assets on Marketplace, including what used to be Unreal Engine Marketplace, it's now called Fab, and Blender Market. And we've also been publishing some educational content on our YouTube channel, talking about how to make procedural tools, materials, and all kinds of content useful for technical artists and game developers. In some ways mimic Houdini or can be used instead of Houdini in some ways. And today I'm going to look into to what extent these tools could potentially replace Houdini and can they. Okay, so first of all, we have geometry nodes in Blender, we have PCG in Unreal Engine, which is under very fast development. We have geometry scripting in Unreal Engine. And then we have other tools like Bifrost in Maya, already have those indie licenses. And then AAA game studios or large VFX studios will go for something like Houdini because it offers all the features including simulation. But what about the developers or smaller studios? There's a bit of a gap in there in terms of people wanting to use Houdini but not really having the resources, whether it's human resources or in terms of licensing budget. The bank all of that was generated interactively in the viewport through AlterMesh running procedural geometry nodes in the background. So yeah, this seems pretty similar to Houdini Engine and what it does. However, we run into a number of issues with that. First of all, we wanted to fracture meshes, but there is no specific fracturing workflow in geometry nodes as of now. Therefore, we had to come up with creative ways of using 3D textures and thresholds and remeshing and things that are not exactly ideal. And then we also didn't have enough volumetric modeling tools to be able to process those meshes later. So we had a collider built in subtools and then run a flip sim, which was first made as a flat tank with just some forces driving the wind. And then the splashes, which we then run a whitewater simulation through. We had to obviously filter the edges and also make it fit inside the bracelet. So the bracelet, to make it easier, we didn't collide with the bracelet, we just filtered it so that you wouldn't see too many collisions in the order of increasing rendering costs. So on the left-hand side, from the top, there's 2D textures, 3D textures. Then there's static meshes. Then we have a set of a mesh plus VAT, a vertex animation texture, which after that we get skeletal meshes and then geometry cache and finally VDB cache using the heterogeneous volumes, which were added in Unreal Engine 5.3. And in terms of rendering, in our case, we used 3 layers, which is basically mimicking the way Houdini would render ocean in something like Karma. So we have an underlying volume, which has absorption and drives the ocean color, which is shifting from blues to greens and all that depth that's created through particles swimming inside the ocean. So for instance, for the main cup splash, we use surface tension and the ground splash sample. And then we have a helix splash, which uses pop fluids. And then there is a pink splash, which uses the pop curve force. And then a lot of volumetric modeling on top. Do we need Houdini? Yes, we need Houdini more and more, especially with multi-platform games. I'm sure many of you work with multiple platforms and understand the challenges. Houdini has competitors now, but we believe that it is still the go-to solution for procedural content. As I mentioned many times during the talk, Side Effects Labs is great and offers incredible value. And now in terms of licensing for game art-oriented use, Houdini Core might be the best choice for teams or individuals looking for R&D simulation and detailed effects. Houdini FX is recommended.